Good morning, ma'am. I am Ranjit, B- BECSC, Department of BECSC. We are talking about the topic of kruskal algorithm in the algorithm analysis. Kruskal algorithm is a greedy algorithm used to find the minimum spanning tree of a connected, weighted and underrated graph. The MST is a subset of the edges that connects all vertices with the minimum possible total edge weight without forming a cycle. The kruskal algorithm is mainly used for to find the minimum spanning tree with these conditions connected weighted and underrated graph, and then to go the steps of kruskal algorithm. Sort all edges in the graph in ascending order based on their weights. This point is important for to explain the example to memory it. Initialize and memory empty MST, a subset of edges. Iterates through the sorted edges and add the smallest edge to the MST as long as it does not form a cycle. Cycle is not nothing bad, it's a loop. It does not form any loop. A cycle is detected using disjoint set union DSU union find with path compression and union by rank. Repeat until the MST as can exactly v minus 1 edges, where v is the number of vertices. Advantages and disadvantages. To to see it advantages and disadvantages. After that, we look the examples. Time complexity also to explain last. Kruskal algorithm. What is mean by kruskal algorithm? We talking later. To find the minimum spanning tree. We explain it. How to minimum spanning tree conditions, steps, how to include it. After I explain it. I will explain. To see the example structure A B C F D E D. It contains the two steps to memory the steps of kruskal algorithm. First point is what? It contains weighted underrated graph. We look the for example, it does not contain any directed graph. Directed graph, underrated graph is nothing but it contains arrow with the edges. We any arrows there is it? No. So it is a underrated graph. So we look the problem tree edge sorted edge illustration. Tree edge is the first step. Tree edge is not initiated. So why is not initiated? So it does not contain any visited nodes, visited edges. It does not contains any vertices. So sorted edges BC, EF, AB, BF, CF, AF, FD, AE, CD, ED. This not any this not any rather. So BC 1 2 3 4 5. How to write it? This is the this I will write. I will explain. Sort all edges in the first point. Sort all edges in the graph in the ascending order based on their weights. So I write it the ascending order of the edges. BC, EF, AB, BF, and then BC is the first node. Why this is the ascending order? This is the smaller. So BC, to take the BC to contains the vertices 1. So to draw the tree must B and C to vertices 1. So B and C is the visited node. Visited nodes is visited nodes is nothing but it is visited by the vertices 1. So to pass the tree edges. So BC is the second point. What? BC is the tree edge, and then EF. EF contains 2. So we draw the map E and F to draw the tree. Sorry, map. So no map is tree. So E and F contains 2. Number of vertices 2. Okay, and then EF is a visited node. So then go to the tree edge. After then a comma b, ab, it contains a value of 3. So to include the map, to include to include the tree, one by one step to look the tree contains any loops. So it does not any contains loop. It's a very important point, must. After then ef does not any contains loops, no, does not contain any loop. After then fourth point, after then fourth point, ab is a visit node, so it adds to adds the tree edge. And then bf contains 4, so bf is not any loop, form a loop, no. So bf contains any loop, no, does not contain any loop. So we add it b and f to draw the vertices in the tree. And then bf is a visited node to add the tree edges. After then cf is a cf to take it the cf, and the number of vertices in contains 4. So we draw the tree cf bfc. To look at the tree, I just draw the c to f. It contains loop. We already see it kruskal algorithm, this does not contain any loop, so it is this contains loop c and f. So c to f to form a cycle or loop, so we neglect it. Okay. And after that cf is not neglected, but it is a visit node, so add the three edges. After then to take it af 5, fd ae cd ed. Okay, af to take it, af it contains the vertices 5. Af also to form a cycle, to see it a to f is a form a loop, so it does not take it and neglect it. And then af is a visit node, so add the three edges. fd 5, the number of vertices vertices 5. So d contains separate, so we draw the draw the tree, so it does not contain any loop. So after then fd is a visited node. After then to move the fd in the tree edge. After ae contains the number of vertices 6. 6 is ae to form a loop, so ae to neglect it. After then ae is a visit node, so to add the tree edges to. After then two edges are that's it. So cd to take it now. cd contains loop, to see it cd it contains loop, so we neglect it. cd to form a cycle or loop, so we neglect it. After then cd is a visit node to add the tree edge. After then ed contains 8, the number of vertices 8. So to draw the ed, okay. ed contains loop. This is a ed, it contains loop, so we neglect it. After then finally to add the vertices, to add the weights. The vertices are weights, similarly vertices are weight, okay. So we add it, 3 plus 1 4, 4 plus 4 8, 8 plus 2 10, 10 plus 5 15. The number of minimum spanning tree kruskal, the answer is 15. The total weight is 15. Thank you for supporting, friends. Thank you.